Going to look eerily familiar to yesterday, because what we said yesterday was that we were going to define the locus definition of a circle, right? And we said that the locus definition of a circle is what? It's the set of points that are a distance away from a center, right? Okay, great. Well, I'm going to give you a new definition, okay? And what it's going to be is it's going to be a locus of points that is, ready? The same distance from a line and a point not on the line. So, let me explain what that looks like. I said that I want the locus of points that are a set distance away from a line. Here's a line. And a point not on the line. There's a point not on the line. Okay? So I want to find things that are the same distance away from both. Well, I think one of those points is easy to find, right? Right here. Would we all agree? Yeah? Okay. Now, I got to find more points, okay? If I was to put a point, let's say, here, okay? Guys, if I was to put a point here, then this would be true. The distance from here to here would match the distance from here to here. Okay? Is that making sense? Yes. If I put a point here, then the distance from here to here would have to match the distance from here to here. Okay? If I put a point here, the distance from here to here would have to match the distance from here to here. Okay? Would you guys agree that this couldn't be a point? Why could that not be a point? Because this distance is much smaller than the distance from here to here. Okay. Now, so do you agree that I would have these points? But then I would also have points what? On the other side, right? So if I put a point here, then this distance would match that distance. Okay, by the way, when I'm going to this line, I'm always going in what direction to it? Give me a word. So I'm starting with a P. Not parallel, perpendicular, right? Parallel would mean I'm not going to go towards it, right? So perpendicular isn't the shortest distance to anything straight line to it, perpendicular to it, right? So if I wanted to get to that wall as quickly as possible, I wouldn't walk that way, right? I would walk straight to it perpendicularly, right? Okay, so the distance from here to here is always going to be perpendicular. And then it's going to match that distance, right? So if I put a point here, then it would be presumed that this distance would match that distance, right? And if I put a point out here, then it would be presumed that that distance matches that distance. And so ultimately, what do we wind up getting? We get a shape that looks like that. It is parabolic, okay? So that's called a locus definition because we're meeting a criteria, okay? We're meeting a criteria. So what are we going to do with that? Well, first thing is this. How do we identify something as being parabolic? Well, we recognize that the equation has a what? Has an x squared, right? What did I say yesterday? We recognize something as being a circle if we have a x squared and a y squared, right? We need both, okay? All right, so it also says the parabola, right? So nonetheless, the parabola is shown below with selected points shown. For this parabola, its focus, okay, that's a new word. Let's write this down. Its focus is 0, 2. Guys, up there on the sideboard, right? That red dot is the focus, okay? So when I said I want to find points that are equidistant from a line and a point not on that line, the point not on that line is the focus, okay? So here, the focus is going to be this point right here, okay? And its directrix, that's another new word, right? Directrix. Guys, up there, the directrix was the actual what? Was the actual line, okay? So this would be the directrix, all right? So those are three new phrases. Locus, point, definition of a parabola, directrix, focus,
okay? So again, to correlate to what I did over there, the directrix is the red line, the focus is the red dot, the locus parabola is the green shape that looks like a parabola, okay? Everybody okay with that? Great. How far is the vertex of the parabola from both the focus and the directrix? So if I look at this little picture here, it says, how far is the turning point of the parabola? Would you agree that the turning point is right here? How far is that point from the focus? Not a trick question. 1 unit. How far is that turning point from the directrix? 1 unit. So does that point meet the criteria of being equidistant from both the focus and the directrix? It does. Okay, good. So let's go back over here. So how far is it? It was 1 unit from both. Now that was really easy to do because we simply could look at our picture and count, right? Now I'm going to change the conversation. I want to verify that this point here is in fact that of the locus of points. I want to make sure it actually works, right? So if this point is on the parabola, and it certainly appears that it is, then what should be true? Then the distance from that point to the directrix, right? So the distance from here to here better be the same as the distance from here to here. Well, this distance is easy to find, right? Because I can simply what? Count it. Yeah, so let's count it. That distance is from here to that directrix, right? So what is that distance? 1, 2, 3, 4, 5 units. All right, so if that point is accurately placed, then this distance right here better be what? It better also be 5 units, right? Well, luckily we have a distance formula to check that, don't we? So I want to know, is 4, 5 units from the focus, and where's the focus located? At 0, 2. All right, so is the distance from 0, 2, is the distance from 0, 2 to 4, 5 equal to 5, right? Is the distance from 0, 2 to 4, 5 equal to 5? So I'm going to use my distance formula, right? I like setting that guy up like that. Some of you the other day, we said we could use the Pythagorean theorem if we wanted to, right? So if you wanted to use the Pythagorean theorem, you could. If you want to use the distance formula, you can, right? So what does my formula say? It says I got to take the difference of the x's and the difference of the y's. So I'm going from 0 to 4, that's the difference of my x's. I'm going from 2 to 5, that's the difference of my y's. Now, really quickly, let's suppose that Ariel was in the bathroom when I was going through this part, and she walked in the room, and she did this on her own, and instead of doing 0, 4, and 2, 5, she did 4, 0, and 5, 2. Well, think about it for a minute, guys. What's 0 minus 4? Negative 4. Negative 4 squared is what? 16. Now, if Ariel comes in the room from the bathroom, and she switches it, and she does 4 minus 0, what's 4 minus 0? 4, what's 4 squared? So does it matter what order those go in? No, right? Doesn't matter, okay? So here I get the square root of negative 4 squared and negative 3 squared, which is the square root of 25, or 5. And so we have verified that, yes, that point meets the locus definition. Because why, guys? Give me a phrase. That point is equidistant from both the focus and directrix. There you go. Okay, that's good. That's a good mathematical phrase, right? Now, it says use the distance formula to show that this equation is based on the locus definition of a parabola. Hint, let xy be any point on the parabola. What? What does that even mean? Well, let's do this. Ready? There's my parabola, right? I'm going to put some random point on this parabola right here, and I'm going to call it x comma y. Now, what do I have? I have some point called the focus. I have some line called the directrix. Now, what do we know? We know that this point right here is equidistant from the directrix and the focus, right? We also know that this point right here, if it's on the parabola, better be equidistant from the directrix and the focus. Now, I didn't draw this very well. Maybe I better draw this a little better, just to sort of like make it look reasonable. That didn't look even reasonable. All right, let's put this point more like, that still doesn't even look that reasonable, but nonetheless, would you agree that the distance from here to here better be the same as the distance from here to here? All right, good. Ah, that's a terrible spot. I'm sorry, guys. I just gotta make this look a little better, just for my own sanity. All right, there. That's a little better. All right, so guys, let me show you something that you know is true. Can you easily find that distance? Can you easily find that distance? Yeah. In fact, you can say one letter to tell me what that distance is. Y. It's y, right? It's however, it's whatever this value is, because how do I get to this point? I go left or right, and then I go up or down, right? So to get to this point, I have to go y units up. Does that make sense? Okay, so this is a y. All right, great. So what do I know? I know that this distance right here better be what? Better be a y also, right? That better be a y also. Okay, well, what is the value of the focus? They said the focus was the point, what? 0, 2? Okay, the focus was 0, 2. So here's what I'm going to do, guys. I'm going to find the distance from here to here using my distance formula. But I'm going to do it generally with the x's and the y's, okay? So my distance formula says, all right, so it's going to be what? It's going to be the difference of the x's. So I can either do 0 minus x or I can do x minus 0, right? Squared. Actually, you know what? I'm going to do it the other way around. Only because, guys. Only because what am I gonna do here? If I do x minus 0, then here I got to do y minus 2, right? I'd rather do y minus 2 than 2 minus y. Now, there's my formula, right? And again, Brianna, what does that represent? That represents the distance from the focus to any point on the parabola, xy. Agreed? Now, what should this equal when I do it? It should equal this distance, right? Which is what? Y, right? So this distance from here to here better meet the same distance from there to there, correct? Okay. So how am I going to evaluate this, guys? Well, how do I get rid of the radical? How do I get rid of the radical? What do I have to do? Square both sides. Okay, so when I square both sides, I get that. Okay. Guys, what's this going to give me? What's x minus 0? X, right? X minus, so this is just going to become an x squared. Do we agree with that? And then what do I have here? I have y minus 2 squared. Isn't that y minus 2 times y minus 2? Doesn't that require me to do some FOILing? Okay. So I have y squared equals x squared plus y minus 2 times y minus 2. And that's going to make me FOIL that, right? So when I FOIL that, y times y? Y squared. Negative 2 times y? Negative 2y. The other negative 2 times y? Negative 2y. And negative 2 times negative 2 is 4. All right. Now, here's what I'm going to do, guys. I'm going to solve this for y. Now, that seems complex, but it's actually not, because if I subtract y squared, what happens? The y squareds are going to what? Cancel out. So right now I get 0 equals x squared minus 4y plus 4. Right? What did I do right there? I subtracted the y squared. That leaves 0 on this side. Then I have negative 2y and negative 2y. That's a negative 4y plus the 4, right? I said I was solving this for the what? For y, correct? So I'm going to add 4y to the other side. And now I have that. And then to solve for, guys, to solve for y, now all I have to do is what? Divide by 4. And when I divide by 4, that gives me y equals, 4 goes into x squared and makes it 1/4 x squared. And what's 4 divided by 4? 1. And that's the equation of a parabola, right? So what we did is we created an equation of a parabola using the distance formula and the locus definition, okay? Now, I've never, ever seen this process asked on a Regents exam, okay? But nonetheless, we kind of want to have that skill available, okay? And it's really just doing a substitution process, okay? So why am I doing this form of a parabola? Well, here's why. And don't read any of this stuff up here yet. I'm gonna paraphrase that all down here, okay? So what I'm gonna do is I'm gonna give you some vocab words, and we're gonna use those vocab words to create equations. Here's what we got. Consider a parabola with a focus at 0, 7. All right, so can I get that on my graph? A focus at 0, 7 puts me here. And I'm going to put an F on it so I remind myself what that is. And a directrix of y equals 3. Well, y equals 3 looks like this. And that's my directrix. Now, based on that information, if you've been paying attention at all, you better be able to tell me one point that you know for certain is on the parabola. Place it on your paper. If you don't know where that is, then don't fool yourself. You haven't been paying attention. And we should have all placed a point right here, right? Why did I pick that spot? Because it's equidistant from the focus and the directrix. What am I going to call that point? That's the vertex, right? That's the turning point of my parabola. What is that point? 0, 5. That point is 0, 5. Doing okay. All right. Now, give me another piece of information that you know is true. Well, you know that this parabola is going to open up, right? So do you agree that you're going to have an x squared in your equation? All right, good. This says determine the equation of the parabola using the locus definition. Guys, there's a couple different ways that we could do this. I'm going to show you what we just did, and then I'm going to do it a second way. All right. So Brandon, here's what I'm going to show you the first way. Okay. Do you agree that there is some point on this parabola that I can call xy? All right. So there is some point called xy. All right. Do I know what that point is or where it is? Not really. I'm just going to randomly place a point maybe here. Right? Now, that's probably not an accurate spot, but I'm just going to call it xy for now, and we'll come back to it. Now, again, if you've been paying attention, what do we know about that point? We know that that point has to be equidistant from that and what? And that. Now, do we all agree that we know one of those lengths? We know this length, and this length is always going to be equal to what? The y. So we have to be equidistant from some point called xy and the focus, which is where? At 0, 7. Okay? So what does our locus definition say? It says that this better be equal to that. And if I use my distance formula, I can do what we just did on that previous page, right? Okay. So my distance formula, I want to see what the distance is from here to here, right? So that's from some random point xy to the focus, right? So I'm going to do x minus 0 and y minus 7. Now, let's go over here to the value of d. Guys, what do we know that this distance here better equal? It better equal y, right? So I want that distance to equal y, right? And that's the distance from the random point xy to the directrix, right? Okay, so what are we going to do now? I want to solve for a y, right? So I got to get rid of the radical first, which means square both sides. So now I got to FOIL this, right? So it's going to be an x minus 7 times an x minus 7. Or I'm sorry, y minus 7 times y minus 7. Foiling y minus 7 times y minus 7 gives me y squared minus 14y plus 49. Now what am I going to do? Well, I got to solve for y, right? The good news again, guys, if you're doing this right, this is always going to happen, is what? This y squared and this y squared will cancel, right? Because you subtract from one and the other one becomes 0. So subtract y squared from both sides. That gives me 0 equals that. Now I got to move this term over with the 14y because I'm trying to solve for y. That gives me 14y equals x squared plus 49. And so divide by 14. And that is an equation of my parabola. Again, how do I know it's an equation of a parabola? Because what do I have? I have an x squared. Okay, cool? Now, there is another way that we could have done that problem. We'll talk about that in a minute. Cool? Everybody good with that? All right, so here I give you a different version of things. Things have switched, things have changed. I give you this. Give me a piece of information that I know right now. I know this is the equation of a parabola. How do I know it? Because x is going to wind up being squared. I know that. Do you guys agree that I could divide both sides by 12? Right? Because this 12 is sitting here, right? If I divide both sides by 12, that's going to get rid of this. That's going to be important. We'll talk about why in a minute. Look at that. Do you guys agree that if this is being divided by 12, that's the same as multiplying by 1/12? Dividing by 12 is the same as multiplying by 1/12. So I'm going to rewrite that to look like this. All right, I'm going to stop there for 1 second. Doesn't this form look kind of familiar to that form yesterday from the circles, where I have the x with a number and the y with a number? It looks kind of familiar, right? And yesterday we wound up taking the opposite signs to find the center. Do you remember doing that? Yeah. Well, I'm going to show you something about this particular parabola. If I put this into my calculator, and I do so as a relation, I have y plus 3 equals 1/12 of x minus 4 squared. All right, there's my parabola. Okay. I want to figure out what this point is. What's that point called again? The vertex. Is that vertex a max or a min? All right, so I'm going to go to the minimum. Look at where the vertex is. The vertex is at 4, -3. Look at our equation. Doesn't that correlate really nicely to what we did yesterday, where the signs of the center of the circle had to be the opposite signs? Okay, so this form right here, guys, is really nice. This is called the locus form of a parabola. Okay, and so what this gives me is it gives me the vertex very easily. The vertex is again going to be the opposite signs of what we have. So I can tell right away that that point right there is the vertex. Okay, now, one more thing I got to do. Ready? This says find the focus. What else do I know about this, guys? I know what that is, right? And what's that? That's the directrix, right? So where is the directrix? The directrix is at y equals -6. 4, 5. There's my directrix. Okay, really quick question, guys. How far is the vertex away from the directrix? 3 units, right? So how far should the focus be? 3 units. So wouldn't the focus be right here? At 1, 2, 3, at 4, 0. We've answered our question. Okay, so giving us the equation in this form is actually very convenient, right? You guys doing all right with that? All right, last question of the day. Write the equation of a parabola with a focus of 8,2 and a directrix of y equals 6. Okay, I give you the focus. 1, 2, 3, 4, 5, 6, 7, 8, 2. There's my focus. I give you my directrix. 3, 4, 5, 6. There's my directrix. If you've been paying attention at all, you know exactly where the vertex is. Plot it. Right there, right? The vertex is at the point 8, 4. Okay, so what am I going to do, guys? I'm going to look for the equation that has an x minus an 8 and a y minus a 4, because it's like yesterday with the circles, right? The opposite signs. So do I have one with an x minus 8? Yeah, I have two of them, right? Both this one and this one. So it can't be this and it can't be this, right? And then I need a y minus 4. Well, I happen to have both of these having what? Y minus 4s. Okay? There's one more thing I got that I'm going to use to figure this out. Okay? Guys, if you see this picture, can my parabola look like this? What's wrong with that? There's no way that my parabola can go through my directrix, right? It doesn't make any sense. That's not going to meet the conditions that we talked about over there on the board, is it? No. So in order to draw my parabola, if my directrix is up here and my focus is down here, it's got to what? It's got to go that way, doesn't it? Yeah. So guys, hey, the rules haven't changed. If the parabola frowns, what's the x term? Or I'm sorry, what's the x squared term? Negative. Well, guys, look here. The x squared term is what right now? It's definitely positive, right? I'm going to divide by 8. Would that change the sign of the x squared term? No. But here, I have x squared, but then I have this negative 8. So were I to FOIL all this out and divide by negative 8 to get y alone, do you see how the x squared term would become negative? Okay? Not to mention the fact, guys, that I could have done what? I could have taken any of these and plugged them into the calculator as a relation to see which one matches that picture. Okay? Locus definition, very similar to what we did with the circles, isn't it? Okay? Guys, that's it. All right, so when I see you guys on Tuesday, right, we're finishing our unit with our exam, okay? You're turning in the remainder of your homework assignments, and we will be done with this long unit. This was a long unit. Yep. That's fine. You can turn that in with the next assignment. That's fine.